Okay, we've started the recording. Do you hear this beep as well every time it comes?
It came just now, but don't know if it'll come again. We'll let you know. Like a screech
So
sound.
Rahul, I'll make you the co-host as well. And I'll add a few more guys. Amit, I'll make you as a co-host as well, just in case. So if you want to add
Okay.
people, you can always add people. Probably Siddharth, I'll make you as a co-host as well. So, just in case I get dropped or something, then at least you can take over. So, okay, we have guys joining. Okay. I'm expecting at least 10% of the audience, to be honest. We are 400 plus now. So at least 10% should join. That's what my aim is. Okay, good. Okay. So, okay. I'll start exactly at 2 minutes past. Let everybody join in. Okay, guys. So welcome to another session on Learn to Thrive. I'd say it's really good to see so many passionate and enthusiastic folks who are actually joining our community. So a lot of people say that AI is a race and we need to run. So I actually think that AI is actually not a race. It's actually a marathon. And it's actually marathon season here in UK. So I was thinking that it's why it's a marathon, because the thing is we all are running together, and the good thing about marathon is that you are not competing against others. You are actually competing against your personal best, right? That's the best thing. What I feel about marathon is that you are trying to improve yourself, and you're also running together, and that's what we are trying to do as well. And with this marathon, we have to start today or tomorrow. I think everybody has to run this. So if you don't do it today, uh, it's better you do the earlier the better, as I say. And the other thing is about growth. So I think what I feel is that we need to actually keep growing. So we need to keep growing our community. We need to have more passionate guys, more enthusiastic guys who are actually working in this field. Only then we can really learn from each other, and that's what the motto is: learn to thrive, right? So what I'd like to say is, if you would like to share the join link, so we have the WhatsApp join link, please use that and share it with your friends, your colleagues. And the other thing is, sometimes I do share the Learn to Thrive community link on my LinkedIn. And if I post that in the group, if you can just take 10 seconds out, it hardly takes 5-10 seconds, guys, really. Just like that post on LinkedIn or do a repost. Or if you are kind enough, then there is a repost with your thoughts. So there are 3 ways: like, repost, or repost with your thoughts. Please post that so that more folks can join, and we can contribute as well. That's one thing. The other thing is, I'm always looking for speakers, right? As I say, that it's a group. We'd like to work together. So I'm always interested in passionate people, good speakers. If you'd like to contribute, please let me know. And yeah, if you have some idea, a thought, and yeah, we can work on that. The next one is around questions. I always say there are no negative adjectives to questions. People say it's a weird question, it's a small question, it's a stupid question. I say a question is a question. So please feel free to ask questions. I know some people are shy. Maybe if you are shy, you don't want to post in the group, do it one-to-one. But try to ask questions, try to be curious, and do not hesitate to ask. Now, I won't stand between you and Rahul, who is our speaker for today. So I actually met Rahul, and I could get that feeling as well. And when he speaks, you will get that as well. He's very passionate guy for AI, And to be honest, when I was actually thinking that I'll be starting this marathon, he was already, I think, 10 laps ahead of me, probably. So when I was talking and discussing with him, and so he's actually here to talk about Agentic RAG, but with a twist of CRAG. Now, this CRAG is something new, and I'll leave that over there, and I'll hand it over to Rahul. So yeah, welcome, Rahul.
Thanks, everyone. Morning, everyone. Yeah, so let's start. So yeah, as I think Joy has very nicely summarized, I think it is not a race; it's a marathon, and I think it's a upheaval for everyone to get into this marathon. And I've also started this journey, but I would say that I'm still catching up on a lot of things. So what you will see today is just my self-learning to what I have learned so far. And it is still, I would say that it is still only scratching the surface. There's a lot sitting underneath. But yeah, we will bring it all together at some point. So let me share my screen and we will get through in the details. I hope everyone could see my screen.
Yeah,
Yes, we
Rahul.
can.
Yeah,
We can see. The only thing is that it's coming as the presenter mode. So maybe you can switch there as well. I think there's a swap display, something on the top. Now, when you do that,
When?
so if you play the slide
Mhm.
on the top, do you see swap displays where it says use slideshow? Yeah, now it's perfect. All good.
Okay. So what you see right now, so the twist is, so this is agentic RAG, but agentic corrective RAG. So what this basically is all about. I think we will get into the details where when you are building the agentic RAG model, we have seen that there are a lot of challenges with the standard RAG one, and corrective RAG is basically improving the input query by grading the response. So if the response is not as per the standard, then the query is rewritten and then the response is generated. Um, so what we look at is we'll just look at a very high level view of agents, multi-agents, and agentic AI. These are the different terms that we will come across. I thought that it's a really good thing to touch base from there. Then we will next get into the details of what are the architecture patterns around agentic systems, quick recap on RAG, then how what are the different design patterns around agentic RAG, including corrective RAG. Then we will look at a very high level view of LangChain ecosystems on which the whole solution is being built. And then we will actually get into the nitty-gritties of how do we build agentic corrective RAG using LangChain and LangGraph. Yeah. So just to take a step back and, okay, what is this AI agents or agentic AI that we talk about? One of the most most popular framework is around React framework. You might have come across. What it is, it is basically reason the question, plan, execute, reason, and then act upon it. So it's basically the agent is giving a thought whether it has got the right information, about what the context query is. It will operate in the different environment. Environment is nothing but the set of tools that you will see. Now it could be a web search, it could be a vector database, it could be a SQL. There is no limit to it. And then it observes, again, rethink whether it has got the right information. If the information is correct, the response is sent to the user. Otherwise, it keeps iterating. And that is the beauty of this model is. Now, so So this is again what we see is, I would still call it as an agentic RAG, but in the true sense, agentic RAG has got certain other characteristics, which is adaptability and self-learn. Now, these are two additional concepts, which is very advanced, and we will get into more reinforcement learning. When if that is applied, then it becomes more of an self-learn, self-adaptive, and that is the true nature of agentic AI. But here, even though agents have got a memory, in this model, but I would not say it is true agentic framework, but you can still call it as an agentic RAG. Yeah. And what are the different other frameworks around agentic frameworks are? So we have got multi-agent systems, which are networks, superior, supervisor, or hierarchical team. This is planning agents are another very popular concept, where predominantly plan and execute, and reason without observation. These are the two frameworks I've seen quite oftenly being used. Then there are others, reflection and critical tree of thoughts is another very good example. And this has also been used in prompt engineering quite well, quite often. Others I've not seen much of an example, but these are other popular other frameworks out there. Then evolution, this is more from I think in the context of Landsmith, they call it. And then experimental, where we have got web search. If you want more of an taxonomic frameworks, then TNT LM is used. Web navigator, competitive prompting, where the agents with few short memory or human in the loop concepts are required. Then competitive programming is quite popular there, or complex and data execution. So these are the other frameworks out there. Some popular net architecture patterns. What we will see today will be more of an single agent, where agent is being provided or exposed to certain set of tools. Today we are using web search, but as I said, other tools can also be used. I will show a very high level system design, which will bring it to life, that what this means. Then there are other architecture patterns like network patterns. So over here, each agent can communicate with every other agent. A supervisor agent, where you have got multiple agents, and there's a supervisor agent which becomes the superior and will interact with other agents. Then another way twist to this is when supervisor agent is given set of tools, then this is where the supervisor as a tool agent comes along. Hierarchical is more complex in nature, where multiple supervisor agents or multiple sub agents are being communicated by one major agent. And then obviously custom agents, where each agent communicates with only a subset of agents, and part of the flow is deterministic, and only some agents can decide who to talk to the other which agent to call next. Yeah, a quick snapshot of these are the tools that I was talking about, which is at LLM's disposal. So if they want to communicate to any other outside world, then they can talk, and this has got no limitation. Like, you can add as many tools as you want, depending upon the business need. Then a quick recap of what RAG is. I'm assuming there is some level of understanding of how RAG operates. In a nutshell, this is the picture. What you are seeing here is called as naive RAG, and then there are other variation to RAG systems as well, but we're not going into the details. So here at a very high level, there are three core components. So one is a retrieval component, which is typically which is composed of embedding model and a vector database that you see here. Where and then the chunking concepts is basically any document, whether it is Word document, PDF, or searching from web. It is been broken down into different chunks, and there are document loader that helps break it down into different chunks. Then those chunks are being vectorized in the file with the help of embedding model. Here I'm using OpenAI, but we can use any LLM models, which is then stored in the vector database. And the most popular algorithm that the retrieval is used is similarity search, and there are other algorithms which I will also give some high level view of what are those. And those similarity documents are being then given to LLM using the user query and the current prompt, and then the final response is retrieved. But the challenge with this model is that this is one shot solution, which means that context is retrieved only once, and there is no reasoning or validation. So it can just pull out whatever they feel like, and it is prone to a lot of hallucinations and bias. So that was a major reason why agentic RAG model concept came out to life. I hope you can still see, or it has switched to presentation mode back.
All good, Rahul. We can see. All good.
Okay. Something has changed in front of me. Right. So what we are seeing here, this is mainly the agentic RAG flow. Now, this is the most popular framework. So let's understand what is happening here. There's a lots going on. So from the left, you'll see the user is, so basically in a nutshell, what we are saying is that an agent is being introduced in the RAG pipeline, which acts as an orchestrator for each component as the process goes through. So when the query is being sent to the LLM, it evaluates the query, and it checks whether the query is in the context of what is being asked. If the and this is where the React framework kicks in. It will check and gives a thought. If the answer is it thinks that no, it is not relevant, then it rewrites and updates the query, send it to LLM for grading. Again, it checks whether it has got the all right context. If the answer is if it says that yes, I've got all the context, then LLM generates the response. Against double check, if the response is correct, response is finally sent. Otherwise, it goes into the cycle. Now here, what it does is, this is an additional step where if it sees that I do not have more, I need more information, then it will reach out to its tool set, whatever is available, whether it is vector, go to web, read out anything from Wikipedia, or do a SQL search, or call an API, whatever whatever tools are available to its disposal. It makes the decision, pulls the information, again goes into the same cyclic loop until it decides that yes, I've got sufficient information based upon the user query and the given context, and then generates the response. That is the beauty of agentic RAG flow is. Now, there are different variation to these agentic RAG systems. So we just looked at agentic RAG that we discussed in the previous slide. What we will focus on will be more corrective RAG. This is quite an easy thing to build. That's why I've picked it up. Now, what is happening here is question is sent to the retriever node. Retriever retrieves the information. It then does the grading in a binary grading, yes or no. If the answer is yes, I've got all the information, like I don't have to go and look for anything, then it goes to the grader generator node and answer is generated. And if any of the relevant document retrieved, if the grader says yes, more information is required, then it rewrites the query and then go to the web search, generates the answer, go to the generator and generates the answer. Then there are other concepts as well, self-RAG, which is mainly self-reflective or self-grading. Variation to corrective RAG, little bit more complex. There are more decision trees embedded in the pipe. Adaptive RAG is it unites query analysis with active self-reflective. So these are different variation to core agentic framework, agentic RAG. And then SQL agent, this is another quite an interesting one. So these pictures I've taken it from LangGraph website, which at the end I can navigate everyone through that, how I took this journey, how I did the learning. And this SQL one, again, this is the same concept, but I've created this, and this is quite an interesting one that it can go rewrite the SQL query to a quite a complex level. Like if you ask the question, give me a list of customers from whatever database, then says that, okay, I need to go and look at this database. These are the number of tables. I have to pick up this table, rewrite the whole schema, write the SQL query, and then generate the answer. It's quite an interesting one. So I can share the screen, like screenshots, if time permits on this one as well. Okay. So moving on. So this is a very high level visualization of if we were to put together everything, that if we are building a system using single agent or multiple agent, this is what one way of visualization is. So here it is a chat window type. So I've used in one of the projects that I've used Gradio, but there are other similar open source libraries like Chainlet or Servlet. That is quite an interesting one. Gives a out of the box chat interface that you can use, and build an agent, give it a memory, short term, long term, so that it has a previous context as well. These are the tool chains which I was talking about. You can chain them all together through LangChain, and build different agents using LangGraph, and the primary agent can orchestrate. So this is a single agent view, and then similarly this is the multi-agent supervisor model, where you have got a primary agent talking to different other agents, which have got specific tasks to work upon. Yeah. So moving on, this is mainly the LangChain ecosystem, which comes. It's quite an interesting framework. So first one is the two architecture models that is being used as a building block for LangChain and LangGraph. Then there are other integration components. There are other third-party integration providers that we can connect to. There are a lot of open libraries available within the framework. Then for deployment, LangGraph platform, this is more of a commercial level if someone wants to look at. But for us, I've not used LangGraph platform. But for Langsmith, these are certain other out-of-the-box features available where you could do your debugging. There is a playground available there where you could do some experiments directly over there through prompt management is there, and then you can do the testing and monitoring. So we will see Langsmith in action as well when we run the project, to give a flavor of it. Then just a very high level overview of what LangGraph framework is. So LangGraph is built on top of LangChain, which facilitates the creation of cyclic graph, especially for the deployment of AI agents powered by LLM. This is typically how the framework or LangGraph is going to look like. This is exactly what we are developing as part of our Agentic Corrective RAG, where information is retrieved. That information is graded. If the grading is yes, all the information is available, then answer is generated. If any one of the document is graded as no, then query is rewritten, web search happens, and then answer is graded. Now, in this, there are the main core components of LangGraphs are mainly nodes, which are nothing but the LangChain runnable objects or the tools, which is basically these ones. So retrieval node, grader, document node, rewriter, these are all nodes. Then edges and conditional edges, these are the directions through which one node will talk to another. So think of these arrows as edges, and where the decision tree happens, which is when the conditional node will come into the play. And then the stateful graph is basically manages and updates the state object while the process is on. So this is the whole stateful graph is what you will see here. Now, it's quite a powerful framework because it runs on three core principles. One is controllability. You have got more control at the low level. It is streaming first, which means is that you will see as the response is generated, you will see like ChatGPT starts writing the response. That is basically the streaming first. And there is a concept of human in the loop where it waits for human response before the next step happens. So that feature comes out of the box. Okay, so let's switch to our mini project. So what we are doing is nothing but we'll do the data ingestion, load it. So I've used Wikipedia to pull some information. That information is then stored in vector database. I've used ChromaDB here. Then agent is built based upon LangChain and LangGraph, and then we'll see the whole workflow orchestration. So any question so far before we switch to the demo?
No.
Hi, Rahul. Quick question. When you say vector store setup, what does that exactly mean?
So vector store is nothing but a vector database.
Okay. It's a database, basically.
Yeah.
Is it like something specific to Gen AI, or is it like the generic database which is available that can be used for something else also?
Yeah, so vector database is basically, think about it as all the embeddings are stored. It is another form of database which is being designed to store embeddings, which is basically the vectorization. So vector database, think of it as a simple table, SQL table, where information is some numeric value is stored against the context. So you should remember that when we were talking about chunking of the information. Let me quickly come back to that. 1 second. Yeah. Let me share my screen again. Okay. Can you see my screen?
Yeah, yeah.
Yes.
But yeah, now that's also good.
It's a presentable mode or
Yeah,
full
it's
screen mode?
all good now. Yeah.
Okay. So when the documents are broken down into small chunks, yeah. So these chunks are then stored in a form of a table. Now the table will have a unique identifier. Its vector is nothing but a numerical value in a simple terms, and then that document chunk, that what this numerical value is represented to. Yeah, so simple 3 or 4 tables that will have numeric 1, 2, 3 or whatever. It's a big number, and then that particular record.
Okay.
Yeah. So maybe Manoj, I'll add further to it what Rahul just said. So previously, as we know, there were relational databases like Oracle, SQL. Then this concept came of vector databases because we needed a persistent store to store the vectors. Vector is nothing but, as Rahul stated, it's an embedding. It's a, if you can think of it as an array of numbers, right? So this is where vector databases came into the market. Like Rahul has used ChromaDB, but there is Pinecone, ChromaDB. Then there is one from Azure as well. Now, Oracle has started giving Oracle 23 AI, which has got vector support. All they have done is, think about it, they have just done is they have created a new data type, and that data type helps to store the vectors. So that's all it is as such. Yeah. Rahul, oh yeah.
Okay, got it. Thank you.
Right. Any more question?
I would recommend folks to do a bit of, I use any GPT to learn a bit about vectors and vector databases, because without that, understanding RAG concept would be difficult for them. And it's a different concept for those who are newly passed out of college. For them, it would be easy to understand, but those who are into industry since last 10, 20, 15 years, it's a different concept than RDBS. So just Google a bit, you will understand after 5-10 minutes of Googling.
Okay. So I hope you can see my screen now.
Yeah.
Yeah. So now let's get into the details of how, I think, one second, let me do a full screen because I can't see now. You can still see my screen?
Yes, sure. Rahul, we can see.
Okay. So here, what we are doing is, so we are building an agentic corrective RAG using LangChain, LangGraph. So we will see the full, project in action, how agentic corrective RAG system can be built. Basically, the idea is to couple RAG system with a grading system and perform a web search if there is a lack of retrieval context of the document in the given query. So how it basically works is, just to bring it to life. You've seen a very high level view previously. So within the given query, vector information is retrieved from the vector database. And this information is given to LLM grader prompt, which basically says that given a query and the context document retrieved from the database, grade each document based on if it is relevant to the query as either yes or no. And then this is what the LLM will do. If the, and it then sends to decision node. If the all documents are relevant, it sends it to RAG prompt. What it says is that given a query and the context document, use only the provided information and answer the query. Do not make it up, which is basically telling do not hallucinate. Just either say you know the answer or do not know the answer, and then generates the answer. If any of the retrieved document is not relevant, it will then say rephrase the prompt, which is more optimized for web search, which is done by again LLM, and then it does the web search, generate the answer, give it to RAG prompt, and then the answer is generated. This is what we are going to build. So let's take things into action. So while this is getting installed, I will upload my configuration file. So what it's doing, it's just installing basic dependencies of LangChain, LangGraph, and then Chroma vector database. I'm using Wikipedia to pull the information, and Rich is just make context pretty, output pretty. That's it. Let's wait for the libraries to get installed.
Running, just for the folks who are maybe new. So Rahul here is actually using the Google Colab environment. So it's really good for Jupyter notebooks and also, and it's free as well. So Rahul, you're using the free one, free
Yeah,
tier?
yeah, I'm using the free one. Yeah.
Oh,
Yeah,
cool.
I should have said this. Yeah.
Yeah, that's fine. That's fine. So that's really good. But I've seen that there are a lot of paid tiers as well. If you are really interested in the GPU side and you want really good processing, then they do offer some paid ones as well. But free ones are really good.
Yeah.
Yeah.
And see, we are using Jupyter Notebook here, but you can run a full project here as well, and then there is a NGROC framework you have to use if you want to run this as a local host, because remember Colab is running on Google Cloud. Therefore, we don't have direct access to the servers. Therefore, we need to build a tunnel to run as a local host, just to bring that into life. Okay, so then because I'm using YAML file as my project config, therefore these are the few dependencies you have to use. So project now document is loaded, API keys. So just to show, even though there are some keys, these are key value pairs. This is how it is used. So I'm using OpenAI, Trevally API. This is for using for the web search. Langsmith tracker and Langsmith API. These are all free except OpenAI API keys. You have to pay for it. Otherwise, Trevally search is free and Langsmith APIs are also free. Now let's load the environment variables. So I'm using OpenAI embedding model. I'm using embedding 3 small. You can use others as well. Now, building the search, I'm pulling information from Wikipedia. So what this code is doing is simply, I've asked the question, pull all the information related to artificial intelligence. It is going to pull that information in some of shape in the document form. So this is how the information is retrieved from Wikipedia as a document. Now this code is simply using, now this is a little bit, if people do not understand RAG, then it will be a little bit challenging, but this is I've not created a full flavor of RAG model, but what simply it is doing is splitting the document that is being created here. This is the whole document is being pulled out. This document is being split into different chunks. I'm using 200 as a chunk size with 300 as a 2000 as a chunk size and 300 as a chunk overlap. Split the document into various chunks. So we will see 68. So it's been broken down into 68 chunks. Let's retrieve first 3 chunks. This is how it looks like, how it's been broken down. Then this code is basically creating the Chroma database. You will see Chroma database being created in a second. So the name will be RAG Wikipedia database, and it is using cosine as a default function, and the database will be created under this name. So if we run this query, see here the wiki database has been created, and this is the embedding database. That's from here. Then so we are using so in this one I'm using similarity and the threshold retrieval as a default strategy, but here are other list of other strategies as well. Now, why I've used similarity with threshold retrieval as a default, even though it is default, but the advantage it will give us is that it will only pick up. It will have a threshold that if the threshold is the similarity search is more than 30%, then only retrieve the information. Otherwise, it will not. So this is one filter criteria that is helping agent to get the right information. So now similarity retriever has been created. If we run the query, this is how the top 3 query has been retrieved from the vector database. Now, for what is machine learning, it has some relevance being pulled out from which is directly linked to artificial intelligence. Now, but if I click ask the question, what is LangChain? Obviously, LangChain has got no direct relevance with artificial intelligence. Therefore, it is trying to pull some information which you can see it is not quite relevant to LangChain. Now, if I say who won the Champions League in 2024, it will say obviously that retrieval do not have relevant information because the score is less than 30%. Now, this is happening because we have used this control. If this control wasn't there, then obviously it will try to hallucinate and bring some information. Now, let's start building the first one. So we are creating a retrieval grader. So what this is doing is simply it is basically it will do the grading based upon yes or no. Now I'm using base model from Pydantic. So this is basically generating the structured output as JSON format. And then LLM grader is being used, which is basically I'm using GPT-4.4o, and temperature means that it has to be very deterministic. No creativity is required. Then because I have to create this as a structured output as yes or no, therefore using the output is being used as a LLM with structured output. The prompt, this is quite an important one. System prompt is required where what basically I'm asking grader to do is that you are an expert grader assessing relevance of the retrieved document. to the user question. Follow these instructions for grading. If the document contains keywords, semantic meaning, relevant question, then grade it. The grading should be either yes or no to indicate whether the document is relevant to the question or not. So grader is then, we are then passing, system prompt, your document and the question. Now, and this is the example of where LangChain is being used. So this is called as LangChain expression language, LCEL. It is a declarative way of demonstrating the chain. Example is the chain example is prompt separated by a pipe going to LLM and to parser. So I'm using it like this because it then gives a flow that grader prompt is sending to structured grader or structured LLM grader. So let's create our grader node. Then let's check whether our grading is working. So it is giving an output. It is saying, when I ask the question, what is machine learning? It is giving an output and generating the grader. Yes. Deep learning, yes. And other classification. So it is an artificial neural network. The grader is yes. So I'm pulling out top 3 documents. Now for what is the line graph, we'll see it has generated that it is not relevant, hence the grading it says no. And if I ask the question, who won the Champions League in 2024, it still says the same, that it's completely irrelevant. So grading is working fine. And now let's build a Q&A RAG chain. So Q&A RAG chain, again, open AI, basic dependencies. So what we are saying is that you are an assistant of Q&A task. Use the following pieces of relevant context in the to answer the question. If no context is present, or if you don't know the answer, just say you don't know the answer. Do not make it up the answer unless it is there in the provided context. Give the details, like this. So question, context, and the generated answer. So prompt is given to the template. LLM is being called, and so this section I'm using to format the whole blob of document. Q&A RAG is given the context to the question. Prompt template is sent to LLM, and the structure output parser basically sends the output, generate the output as a string. So what this is doing is the above piece of code. I've executed or not? No. So it is sending the input in the form of question and context. Format the document. Send these two to the prompt template, and then prompt template is being the prompt is then given to ChatGPT or LLM, and then the output is generated and the final answer is given to the user. So if we run the same question again, just to check whether our generation is working, yes, it is all working, retrieving the information. What is LangChain, LangGraph? So it is now saying, I do not know the answer. The provided context do not contain any information about LangGraph. Now, so this is quite well working here. Then let's create the query rephraser. This is required. So query rephraser is act as a question rewriter to perform the following task. Convert the following input question to a better version that is optimized for web search. When rewrite, look at the input question and try to reason about the underlying semantic intent and meaning. So that's what it is doing. It is simply rewriting the question, sending to LLM and generating the output as a string. Yeah, so let's check whether it is working or not. So it is saying, so we asked the question, what is LangChain? It has rewritten to what is LangChain and what are its main features or users chooses. Now, final is we have to build a web search tool. So it's simply trivially search. I've given a link here where to find, create your trivially API key. It's a very straightforward way of calling it. And let's check whether it is working or not. So it is pulling the answer. So we are saying maximum return 3 results. And then there are other parameters, advance, and what are the maximum tokens you can use. Now, let's build our agent components. So this is what we talked about previously as well. So every time, so the entry point will be retrieve node. Retrieve node will call grader. Document is graded, goes to decision tree. If all the informations are valid, generate the answer. If no, rewrite the query, go do a web search, generate the answer. Now, the first thing that we have to do when we build for LLM land graph is build a graph state. So graph state is basically it's a dictionary framework. So it has got basically 4 components. One is question that we will be asking or providing, then the answer is generated. Web search, if the answer is not relevant, go and do a web search. So we need a placeholder for it, and the full document list. So these are the key value pairs we have to create in the. So this is always the first entry point for generating a line graph. Now, now let's start building the function. So first one is the retrieval function, the first node, which is basically pulling the retrieving the information through from the vector database and returning. So that is a first node being created. Then second is the grader node. So grader node is checking the document whether it is relevant or not. So first time the web search will be no. If and then it goes call the document grader. If the document grader says the return grading is yes, then print document is relevant. If not, then say document is not relevant, and then call the web search. If none of it's completely out of context, any question comes, then it simply says you have to do a web search directly. Yeah. So yeah, this is done. Then rewriter query, as we said, if for the web search, receiving a call. So this is a read. Oops. So query is this is a rewriter node, rewriting node for the web search. Then we have got we have to create a web search to go and do a web search. For that, simply calling the trivially function, and then generator node. So this is simply generating the output from the RAG, from the Q&A RAG pipeline. And then this is an additional function we need, decide to generate. Now this is a decision tree, as we said here. Sorry, 1 second. So this decision function is what we have to create, and that's what that function was all about. Yeah, if the document is so do a web search if the grader says yes, otherwise do not do a web search. Now let's bring did I make this? Yeah. So let's bring everything together. So this is how the agent graph is being created. First, create all those nodes. So first, the entry point will be retriever node. Then comes the grader node. Then you have got a rewriter, web search, and generate node. And then those are the edges we have to create. So retriever will call grader document. Grader will check whether to rewrite or not. If to rewrite, rewrite and then call. Basically, rewriter will call a web search. Web search will call generate answer, and generate answer will end. Yeah, so basically here are the decisions happening, that if the document is correct, directly generate answer and end. If the document is any one of the document is not relevant, go to the rewrite the query. um, um, Web search will generate the answer, and then end. Here there is a small variation, like this is where if you were to create a memory, this is where you will add a persist check, which will basically, depending upon how you want to store the information in the memory, whether it is in memory or create a persist or store it in a database. So there is a parameter here that we pass, which will basically then persist.
Yeah. I think in between there was a slight glitch, but yeah, now it's fine. Maybe Rahul's screen is frozen at the moment.
You can hear, actually, I thought I was told. What's up?
Yeah, maybe there's some echo. The person who's not speaking, can you please unmute?
Why my screen
Yeah,
is
even your
frozen?
video is frozen,
What's
Rahul,
happening?
for some reason. Yeah, now it's fine. Now it's fine. Can you say something, Rahul?
Yeah,
Now
yeah,
it's fine.
I'm actually not.
Now,
Can you hear me?
yeah. Now we can hear you. Yeah.
Wait, let me. Something is not right. My screen is completely frozen for some reason.
Maybe try and reshare your screen if it helps.
Yeah, that's what I'm doing. You can see?
Yeah. Yeah, it's fine now.
Yeah. So let's build the so graph has been compiled. Now there's a very interesting way of visualizing the graph. This is how the whole graph is being created. So we can see we start retrieval node. Retrieval node calls grader document. Grader documents, you rewrite the query, web search it, or generate the answer. Or if the documents are relevant, directly go and generate the answer. So this is this is what we called as a mermaid code. We can see what it does behind the scene. It's a free tool being added here. So it's basically draw the graph pattern here. Now we have got everything in place. Let's see RAG, corrective RAG in action. So the first question is, what is the machine learning? What it does is retrieve from the vector database, check the document to the question, document retrieved, document not retrieved, document retrieved. So we asked for the top three. So what it does is, because it has found one of the document not relevant, it decided to do a web search and then generated the answer. Yeah. You can see. Now let's see what it does for what is line graph. So it says document not retrieved, and decided straight go to web search because it didn't find any relevant document, and pulled out all the correct information from the web. Now, if we ask what is artificial intelligence, so we can see that it has found all the relevant information. Therefore, there was no need to go and look for anything on the web. Now, if we say who won the Champions League in 2024, this is completely out of context question. It simply said no documents retrieved, straight away went to web search and found the right information. So now let's see what happens. This is what I was talking about as a Langsmith in action. So this is where you could see everything happening within the Langsmith. Oh, you come here. You know, what do I do with this? Do you see this small window?
Yeah. I can
Should I
see.
close it?
Try it. Yeah. Yeah, that's fine.
Okay. So here, what it is happening is we are seeing, so we can see everything in action in Langsmith. What is happening? So retriever node was called. It then, so when we asked the question, who won the Champions League? It went to the vector database, looked for document. No document was recovered or retrieved. Went to grader. It says web search is needed. Yes. The output was, rewrite the query. So it went to rewrite query node. And then who won the Champions League? It rewrote to who were the winners of the 2024 Champions League. Went to the LLM, rewrote the question. Did a web search was called, trivially pulled all the relevant information. The information was sent to grader answer, and the answer was generated like this. Now, if we see the previous question, when we asked for what is artificial intelligence, it did the same thing, found 3 documents as we asked for, top 3 documents, which are of 30% similarity. Went to grader. It says over here that somewhere it says that, yeah, web search needed, no. So what it said, yeah, so it did for all the 3. Then decision tree went, generate the answer, node was called, and the answer was generated. Yeah. So basically the whole thing is that it's a very nice tool to see what is happening within the code. Can then see here how many tokens have been used, what was the cost of execution of each LLM, and I can show some error scenarios as well, if it allows me to. Yeah, so see if there are errors, then you can see what happened. So this basically says there was some problem at runtime calling a vector database. Yeah, so these are the different types of ways you could do. And then there are other features as well. You can run a playground as well. In this, play around with the system prompts and this, but you have to, if you start, then it will ask for your OpenAPI key. You do that, and then you can play around with these things. So that was it in action. Anything? Yeah. Anything anyone wants to ask? This is all I have for the demo.
Yeah. Thanks. Thank you so much, Rahul. I think Sujit had a question.
Yeah, I had that question. So I think initially you is it echoing?
Yeah.
So the first one, when you passed the I think that arguments, right? About, if you can go back to the code.
Where?
The initial one where we were passing the argument of LLM and parser and those things, the standard output. I think you passed only couple of arguments, but not the structured parser or something, which was. So I was wondering, like, whether it is the standard format. I think in the later half of the demos, you have covered that pretty well. Yeah, here.
Which line of code you're talking about?
The initial one where you were mentioning about the how you're passing the arguments to the. So you have separated that in 3 different lines, right? Like after the pipe.
Oh, okay. Where is it?
You mean where the chain was being built?
This one.
The chain was being built, yeah. So this
Mhm.
one, like, but this is, I think, the second one where you have put the structured output parser. But in the initial one, I think that was missing, right? So only 2 arguments you passed. I was wondering, because you mentioned that there are 3 which are required, but you
Here.
passed only 2. Yeah, right here.
Okay, so here basically, see, it depends upon what we are trying to achieve as outcome. So this is basically a retriever. It's a grader document. What it is only generating is yes or no. Yep. So
Okay.
here, what we have done is we have called the LLM. LLM is basically generating the structured output as yes or no. That's what it is doing. It is creating a JSON-like object for the binary score.
Okay.
So
That is
that's
the
why we
unique.
don't need these 3 things. So this
Three
is a
things.
standard way of building a chain, but depending upon what type of outcome you're looking for. So
Okay.
here, basically, these 2 LLM and parsers been combined together.
Okay, got it. Yeah. Thanks, Ram.
So we have a question from Abhishek.
Oh, sorry.
Yep. My question basically is on the last example which you covered. Basically, it was really nice demo, Rahul. First thing, I need to basically understand here why graph. We can do the same thing probably by going with the sequential manner to get the answer. I mean, I just wanted to understand basically that what would be the use case for us to go with the graph. That's where I'm a bit struggling to understand that that
So are you debating in your mind whether to go for a graph or a sequential, like LangChain
Yeah.
also provides agent
That's where, yeah. I mean, that's where. I mean, mm, you know, it's that's where you spotted right. Basically, I mean, you got me right. Basically, I mean, whenever you think of the use case, you think from the sequential way, right? And
Yeah.
then the graph example, you demonstrated it really well. It may be having some benefits, but when to use, what is the benefits? I mean, that's
Yeah.
where.
See, I think so the way to visualize it as LangChain also gives you a capability to create agents, but it has got a limitation on creating these type of decision trees. So whenever you are looking for a complex model, like simple, if you remember from my presentation that the first block was that creating a single agent with tool sets. That is a perfect example that you don't need a graph. You simply say, I want to create an agent that will do a precisely specific task where if the it retrieving the information from vector database. If the context is not there, go to web search and or do a calculator, or run a SQL query. For that, it's a very straightforward way of building it. But when you're trying to build these type of decision trees, that if your context is not there, then do A, or otherwise do B. That type of think of as a flow chart. If you're trying to build the flow chart type on framework, then LangChain falls short, and that's where the line graph plays a bigger role. That's how you should see the use case. If you have a very simple agent with a set of tools to perform certain tasks, then yes, no need for creating this complex workflow. But if you're looking for a lot of decision making trees, then it is more. So this is more of an autonomous way of building an agent.
Yeah.
As
Thanks, Rahul. Yeah, understood. Yeah.
A great explanation, I'd say, Rahul. And I'd really say thank you so much, Rahul. It was such an amazing session, and I personally learned a lot. And guys, I think we should do some virtual applaud for Rahul. Definitely, some applause should keep coming. So
Thank you.
it was really nice. Thank you so much. And yeah, any other questions? Otherwise, we should.
Especially the grading one, that was nice. That was very sweet example.
Yeah. Lots to learn. Actually, I never saw LangSmith before, but last night I was talking to Rahul, and he actually showed me LangSmith. It's really amazing, especially the monitoring part. How you can actually troubleshoot the scenarios within LangSmith. It's amazing.
No shit, it's really a good tool. I mean,
Yeah.
LangSmith, it's web-based, free, and it's awesome. Yeah.
Yeah.
I like there. I would like to add some words. So the flow was very good. Initially, it was compact with the information. It was really catchy. Otherwise, some of the sessions are very boring. And then it was followed by the code. Rahul, is it possible for you to share this repo URL so that
Yeah, I'll share the slides and this code. Obviously, cannot share my configuration file.
Yeah, sure.
Not
I
with these.
understand. Okay.
Yeah,
मेरे
but-
साथ share कर ले.
I have one quick question, if
Yeah.
that's okay.
Who's that, Avinash?
Yeah, that's right. So, first of all, thank you so much, Rahul and Joy. That was a very useful session, at least from my point of view as well. The question that I have is, can we have this all set up local to our system? Yes, data confidentiality purpose.
Say that again. Sorry, I couldn't understand.
So, can we have the whole setup in our local system instead of making API calls?
Yeah.
Local systems, yeah, you can. I'm using, one was I wanted to play around with this Google Colab, But and second, my local environment got corrupted, so I don't wanted to touch my laptop, but I have to clean it up. So, but yeah, it is all possible.
Yeah, maybe I can add further to that what Rahul said. So what you can do for local is you can always go with Olama. You can go with Visual Studio Code, Olama. For LLM, you can use any of the LLMs, like Llama models are there which support tool calling. So you can use that if you don't want to use OpenAI. So everything can be local in that case. If you want to save cost and you have concerned about the privacy of data.
And Chroma DB is also local, right? The vector DB created by that.
Yeah.
Okay. And anything else like that?
Milvus, you can check that as well. So they're quite popular. Another one is Milvus database. You can use that.
Okay. And the chaining, the Landgraph thing that to chain the things that you did, that is also
Yeah. Local? Everything is local. You can just install everything on your local environment. So these are all free downloadable components. So, through pip, you can download everything on your local machine.
Okay. So basically, my use case that I'm thinking is like, for example, I want to do something where I can query my resources in my laptop.
Yes.
From doing search and everything. So I just use this to find resources in my laptop, but that includes my office work as well. So I just don't want to make any outside API calls. So that was my use case, which I was thinking of building.
So I think that Olama will be perfect for you, as I said. Use Olama and use LLMs locally on your download the LLM, use Olama, and yeah.
But then you need a very powerful laptop, right? Because I could see my Mac fans were picking off the moment I executed Olama. So
yeah, that's a good point.
It's everyone's problem, bro.
Yeah, so be mindful of that fact. You need a more powerful laptops, but now GPUs enabled laptops are available. If you can get lay hands on, then go for it.
Okay, perfect. Thank you so much. Really appreciate your time. Thank you.
And I think if we can maybe take one last question from Fritz.
Sorry. It wasn't question. No question at all.
Oh, okay. I could see your hand. That's fine. Okay, thank you so much, guys. Thank you, Rahul. Really appreciate it. Cheers, guys. Take care. Bye.
Thanks,
Thanks, Rahul. Thanks, Kshitij.
Thank you so much.